Electromagnetic compatibility. Compatibility, EMC, is an important topic for the radio amateur because it is one of the issues that can cause the most difficulty to the enjoyment of the hobby and the goodwill of neighbours. EMC is the avoidance of interference between two pieces of electromagnetic equipment. Radio transmitters can cause interference to other radio receiving devices and electrical items that are not intended to pick up radio waves but are nonetheless upset by them. How is interference caused? Amateur transmitters produce powerful signals in a home environment. These may be picked up by house mains wiring and the leads to individual appliances, telephone and computer network wiring. TV aerial down leads, loudspeaker leads and metal pipework. At VHF and UHF, the wiring inside devices is often long enough for direct pickup to cause problems. A hi-fi, for example, may be fine in itself and able to tolerate the radio signals. However, as in figure 10.1, shows the loudspeaker leads the FM radio lead connections to a separate record or other music source, or even the mains lead can pick up radio signals and convey them into the hi-fi, which then suffers. Here is a figure 10 diagram. There are a number of ways that transmitted radio signals can enter hi-fi, and have a look here. Pick up on the main power leads, loudspeaker leads, pick up directly in the electronics, pick up FM tuner, antenna, and more. The transmitting antenna may be close to a telephone line, especially if it is overhead on a pole. The radio operator's voice may then be heard on the telephone. Possibly an electronic telephone will be unable to recall stored numbers when the transmitter is operating. It is also possible that the transmitter is sending unwanted RF signal back down its mains power lead, and these are then conveyed via mains wiring into other domestic appliances. Most will probably withstand this, but some may not. There are so many different scenarios that it is impossible to say in advance just what effect might be. What can be done to minimize the problem? Good practice starts in the Radio Shack. There is a lot that can be done to minimize chances of problems occurring before having to consider solutions to particular issues. Many of these precautions will also minimize the chance of the amateur receivers suffering from the interference from other domestic devices and making it harder to hear distant weak stations. First, we need to do a bit more careful to consider the ways in which equipments are affected. Direct pickup. The field strength, the correct term for the strength of the radio wave, may be too high for the affected equipment. The RF signal is picked up by the internal equipment wiring and circuits. This can be more of a problem at VHF and UHF. Cure. Reduce the field strength. Move the transmitting antenna further away, e.g. to the far end of the garden, so long as it is not then close to the neighbor. It also helps if the antenna can be mounted high up above the house wiring and TV antennas. RF conducted from the transmitter along mains cables. RF signals may leak out of the transmitter along its power supply leads. Cure. Prevent RF signals leaving the shack along cables by fitting suitable filters on the power leads to the transmitter. This may be necessary on both the low voltage DC leads and main leads. This will also assist in reducing important interference affecting amateur receivers. RF from the antenna being picked up by various wires and conducted into affected devices. Cure. Move the antenna away from the house. See direct pickup above. Fit filters on the leads into the affected device. RF being fed back into the mains earth wires. Cure. Sort out the earthing arrangements in the shack. If an RF earth and the mains safety are connected together, the connection may need filtering in the same way as the power leads. Earthing. In the Radio Shack, there are two separate reasons for earthing equipment, especially transmitters. 1. As with all equipment that are not specially made to be double insulated, an earth is needed for safety reasons. This earth must not be removed. Most amateur equipment is not double insulated. 2. Many antennas have only a single wire feed. The center of the coaxial cable, there may be a return path for the RF current, and this is normally the earth. If the transmitter is earth to the mains, then the RF signal will flow in the mains earth and via house wiring to the other appliances in the house and possibly to neighbors as well. RF in the mains earth can be avoided or at least minimized by providing RF earth in addition to normal mains safety earth. This is done by knocking a metal spike into the ground close to the point where the feeder enters the house. This is connected by heavy gauge wire directly to the transmitter, or if fitted, the wall socket terminating the feeder to the amateur antenna. To further limit RF getting into the mains, all three mains leads, live, neutral and earth, need to be filtered. This is the best done by using a ferrite ring filter, which the mains lead is simply wrapped around. Ideally there should be about 20 turns, so it might be necessary to use 4 rings with 5 turns on each. There are electrical safety implications to RF earths. See the RF earths and PME section in chapter 11. F10.2, the earth symbol. Choice of antenna. At HF, another very effective option is to use a balanced antenna such as a horizontal dipole. A balun will be needed if coaxial feeder is used, and the RF on the earthed outer of the feeder is minimized if the feeder drops at a right angle to the dipole and not alongside one of the dipole halves. N-fed and HF antennas always need an effective RF earth path. Even so, the end which is fed has a high current or voltage and is prone to cause EMC problems such as direct pickup within the circuitry of other apparatus as well as any pickup by mains and telephone wiring. If an N-fed antenna cannot be avoided due to space restrictions, as previously mentioned, it is best to run the feeder down the garden and feed the antenna from as far end, i.e. away from the house. A good earth on a feeder braid at the feed point is important. Whatever antenna is chosen, it should be as far away from the house, especially neighbors, as the garden will allow loft antennas are likely to cause you problems due to their proximity to house wiring and TV aerials. Power and modes of transmission. The more power a station runs, the more likely problems are to occur at power levels used by foundation licensees. The likelihood of the problem is not high, but it is not insignificant either. The different modes, AM, FM, SSB, and data, tend to cause different levels of interference. The amplitude modulated modes especially cause far more problems than the constant level output modes such as data and FM. Single sideband. This is the worst. The level varies continuously in time with transmitted voice, and the interference caused sounds like a distorted voice, which is subjectively annoying. Data. Many of the data modes have fairly constant transmitted power level and often cause little problem. Morse. CW with smooth changes from on to off can be reasonable, but depending on the quality of the design of the transmitter and the keying circuits. Mobile operation. Fitting transmitting equipment into vehicles must be done with care. The manufacturer's advice must be sought on acceptable locations for the antenna, the maximum allowable RF power, and how to power the radio from the car battery. Any failures in this respect may affect the engine management system, the operation of the braking system and anti-lock brakes, and the correct operation of other car electrical devices. This is an area where professional advice should be sought, as the effect of interference may not be immediately obvious. It is also possible that the vehicle ignition, battery charging, and other vehicle electronics could cause interference on receive. Testing the installation is essential and must be done stationary before any road tests are carried out. All the car electrical systems must be checked. There is an increasing use of the in-car data bus to control the items such as lights and indicators, which are activated by remote switches and sensors, which makes thorough checking imperative. As the vehicle owner or driver, you are responsible for the overall safety of the installation, and you may need to inform your insurance company. Finding you should have done after an incident is too late, and you might find you are uninsured. The ability of equipment to withstand interference is known as immunity. This quality needs to be designed in at the outset, and cost is not always a good indication. The European EMC directive lays down standards of immunity. Most modern equipment is quite good. Nonetheless, many cases of interference occur because the affected equipment is not sufficiently immune. The immunity can often be improved by fitting suitable filters where the mains and other leads such as loudspeakers and FM aerial leads enter the device. Whatever type of filter is chosen, it should be fitted as close to the affected device as possible. With powered speakers on a computer system, both ends of the connected lead attached to electronics, so it may be necessary to fit filters to both ends. Ferrite rings, figure 10.3, are often effective and have considerable advantage that they do not need wires to be cut or equipment opened, both of which have safety implications, and invalid warranty split clip or ferrites are available. See figure 10.4 if the plugs are molded onto a cable. Figure 10.3, how to wind a ferrite ring. Now, how to wire is fed through the ring from the start by splitting, winding the start and the finish ends are kept apart. 10.4, a clip-on ferrite of kind can be used to minimize the interference. There are other filters and good range. A clip-on ferrite of the kind that can be used to minimize the interference. There are other filters and a good range is available from various suppliers, including RSGB, who can offer specific advice on filters in amateur radio use. The RSGB also run an EMC advisory service for members. To assist with any difficulties, the advice service is available via RSGB headquarters. The RSGB website also has several pages of information and downloadable leaflets. Homemade filters are strongly discouraged. Their effectiveness cannot be guaranteed. Many amateurs are well qualified technically, but at the foundation level, the only good advice is to obtain ready-made, tried and tested items. Fitting homemade filters in main supplies is particularly risky, and special mains rated components must be used. It is not a task for the amateur who is not also professionally qualified. For your own safety, do not fit homemade items in the mains wiring. The neighbors. The subject of interference is all more important when neighbors become involved. If neighbors have a problem with your transmission, you have got to deal with it. It really is best if a cooperative and diplomatic approach can be established. Ask the neighbor if you can see what the problem is and carry out tests to see how it can be resolved. Maintaining goodwill is essential if a satisfactory solution is to be found. If you are not sure exactly what event caused the complaint, perhaps your neighbor will keep a simple log of when the problem occurs so you can compare it with yours. It is likely that you will need to stop doing whatever is causing the problem until you can solve it. Hopefully, once the problem is understood, its resolution may not be too difficult. Experience has shown that often it is inadequately immunity on the part of the affected device, so you will not be able to solve the matter on your own. In such cases, it's best to obtain independent assistance, but local TV and electrical shops are largely unaware of amateur EMC issues and may simply blame the amateur, often wrongly. The RSGB EMC committee produced a number of downloadable leaflets on many aspects of EMC, some written in form suitable to give your neighbors. If you are an RSGB member, you can also consult the The RSGB EMC committee. Alternatively, you can ask a local amateur known to have suitable expertise. Your local amateur radio club may be able to suggest somebody suitably qualified.